So, we have a laser here, So, this laser light is fallen on this mirror, laser light is fallen on the mirror, right. You can see now this from this mirror, now reflected ray is coming back and it is falling on a here we have put one graph paper, it is fallen on a graph paper, right. So, you see on a graph paper you can see it is oscillating. Here I can show you this in better way. So, you see this is oscillating. So, let it oscillate, you can see this. Okay. So, when that frame is oscillating, a mirror is fixed with that mirror also oscillating, right, and laser beam falls on this mirror and this reflected laser light is this one and this is also oscillating, okay, because you know that these are basically reflection, right. So, change of angle of mirror by theta, the change of reflected angle will be by 2 theta. Okay. So, when mirror changes by theta, reflected angle will change by 2 theta. Okay. So, mirror is oscillating, it is a changing angle, right. So, say by theta. So, this reflected ray it's oscillating by 2 theta, okay, or this angle of reflection will change by 2 theta, right. So, this laser beam is fallen on this graph paper. So, now think that this what I can do for measuring D0. So, I have to first, it is still oscillating, I have to wait for or I have to make it in rest condition. Okay. Still oscillating, I have to so I can take it in middle also, just slight changing angle. No, it is going out, so I think I have to. Okay, let it be there. So, I have to wait. I think to stop it, there is, I don't know, some tricks we can apply. I think it may help. Okay, just okay. So, my hand is shaking, so that is why also it is. So, I think one can, let me try to make it steady. Okay, yes, it works, it works. Okay, so actually you should not use any fan, or I should not talk much also. Okay, so then it will start process. So it's more or less steady. Okay, so what I will do, so this the steady position, I will mark it. Basically, if slightly it oscillates, that also is a mean position of the oscillation, you should find out. So I will mark it, this position. Okay, so actually I can take this yeah, I think this the position I can take it. Okay, this is the position I can take. Now I don't know this whether I can see this mark or not. Let me check it. Yes, so it's there. Okay, it is there. Okay, see, with respect to this mark point, it is oscillating. Fine. So this is the original position in steady condition, where this air gap, that distance d0, this air gap we want to measure. So this is the position of the light, and when it will be at this position, then this air gap, that we define that air gap is d0. Now what we will do, if we touch these two, okay, now if I touch these two, for touching these two I can put one weight, I can put one weight, you see, I have a weight box, I can put weight, say it's 200 gram weight, I will put 200 gram weight, whether you can see is the 200, not gram, milligram, 200 milligram weight. I have placed to put the weight here, I have placed to put the wire, put the weight on the wire. So I think yes, I will, here you see there is a place, I think I will touch and hold it and put this wire. Okay, okay. So now these two wires touching each other, just I put weight, so it's rotated down, it's rotated down. Okay, it rotated down and touch each other. So when they are touching each other, then you see, and it is touching each other, you will be sure that it is not oscillating, it is not oscillating. Okay, it's just immediately. So now what I will do, I will just mark the middle point, I will mark the middle point, I will mark the middle point. Okay, I will mark the middle point. Okay, so now this distance between these two point, that we will note down. So here it is millimeter graph paper. So how many points are there? I think this 1, 2, 3. Okay, 3 complete one, this 30 millimeter, and then here 7. I think, yeah, I will take 6, 36, and here it's 5. Here it is the 5. When I will take out this mass, I can see it's at 5. So 30 plus 6 plus 5, 41 millimeter. Okay, so this one is 41 millimeter, but this is not d0. So we have to find out d0 from this geometry. So that I will basically tell you that that measurement of d. So you see, so this upper part I have drawn, okay, upper part, this I have drawn. So here mirror is here, okay, mirror is here. So and I put weight here, and then it touch this bottom wire. Okay, so when it touch this bottom wire, that means it's rotate. Okay, and then mirror also rotate. So, if mirror rotate by when it was here, with respect to this, now mirror rotate by angle theta, because of that then this light is basically reflected one. Now angle of reflection is changed by 2 theta, and because of this 2 theta, change of angle of reflection, so this reflected ray now it came here. Okay. So now this, when it was in this position, in this, so this you can take one line, okay, one distance. So this distance is basically, mirrored to this scale graph paper. So the distance, if we define by b, and this deflection here, so this is the displacement of this light spot, reflected light spot, if it is capital D, this is B. So basically what happens? So this is the original position. Now then it's rotated by angle 2 theta. Because of that, the ray is come down and it is falling here, and you add these two. So this tan 2 theta will be that this divided by this. So that will be this d divided by this distance, if it is b, d by b will be tan 2 theta is equal to d, capital D by b, right. So since this angle is very small, so tan 2 theta we can write 2 theta, right. Now you see here, this lever, this axis of rotation is this, where mirror is there. Now another this arm, this wire, this top wire, whatever, this arm, okay, the distance between these two is if it is a distance between these two, okay, this is the axis of rotation, and this wire, top wire basically, if distance is a and mirror is here, right, mirror is here. So if mirror is rotated by theta, okay, so there will be deflection of this arm, okay. So that, because it is fixed with this, okay. So forget light. So with light we have done, okay. Now without light also, here you can see this something is rotating, okay. So with respect to this axis, now this distance, now this another thing is fixed with this one. So what will be the deflection of this one? Then this angle of rotation is theta. So again the tan theta will be that deflection, if it is say it's the basically in this case this one is basically d0, okay, because these two wires, this top wire touches this bottom wire, okay. So it's this deflection is basically d0, okay, whatever the air gap, this d0. So tan theta will be this d0 by that distance, okay, this arm distance, sorry, this distance, okay, distance from the axis of this wire, top wires, okay. So this, if it is this a, if this is a, so basically here mirror is rotated by theta, right. So this part, okay, this distance is a, then this is d0. So tan theta will be d0 by a. So for small angle of theta, tan theta we can write theta. So from here you can get that theta equal to d by 2b equal to d0 by a. So d0 from these two, d0 is equal to d, capital D small a divided by 2 small b. Okay. So you will get d0 if you know capital D. I know capital D. Okay, that is the 41 millimeter. Now I have to measure A. So I will measure A this one. I have meter scale. I have meter scale. Okay, I have meter scale. So I will use it and I will measure this length of this arm. Okay. Okay. So this one should take this reading. Okay. Since I am speaking, so it's difficult to just read the reading, but this is the you can take this reading. So this is A, and what I need B. What is B? B is the distance of this graph paper from this mirror. This. Okay. So for that I think this is not enough. So I have tape. Okay. I have tape, measuring tape, so I will use this one. Okay, I will use this one. From here I have to take. So since it's a very long distance, so this one should take the reading. Okay, whatever. So that will be the B. So now B is measured using the measuring tape. You need the least count. So least count of this tape you should see, find out, okay, and note it down. This is 1 millimeter. Okay, this is 1 millimeter. I have used meter scale. Okay, so this is also 1 millimeter least count. Okay, then so for capital D also I have used millimeter. Okay, so this is the least count of this graph paper is millimeter, 1 millimeter. So for all length measurement, so we have used the scale which is having the least count is 1 millimeter, that we should note down. So this is the way we will find out D0. We will find out D0. So this part is done. So what is left in our formula, working formula? What was there? It's a mu equal to 2 pi d capital L divided by capital L f by I square. So this d I have measured, this d I have measured, R1, R2 as I showed from using slide, not slide calipers, using screw gauge, and d0 using this optical method. These are generally tell light mirror arrangement, light mirror or light lens scale arrangement. So, so from here we were able to measure the D, whatever we need in our working formula. Next we have to measure L length. That is easy. Again I will use this one. Okay, meter scale. And what is the length that you have to measure here? Yes, this just take reading and find out what is the length. Okay, so L also using this meter scale we will measure this length, because it's a 1 millimeter and this length looks to me it's more than 20 centimeter. Okay, means 200 millimeter. So that's why error 1 millimeter least count. So just you can take. Okay, so you do not need to be very cautious because error you know this delta L by L. Okay, delta L is 1 millimeter by L, that if it is L is very small, if it's 10 millimeter, then you have to be very careful. If it is 200 millimeter, so then fine, and casually you can just take reading. So D and L, that is done. Now next part is this f by I square, that we have to measure. Okay, so this also we have discussed how to measure d0 air gap. So, that is done. Okay. Now, let me discuss this how to what is f and I square. So, that how we can measure that I will discuss. So, basically you see, so force is here Lorentz force between two wires, and that is because of the current flowing in these two wires in opposite direction. So, that will be repulsive force. Okay. So, the attractive or repulsive there does not matter, but here we are considering repulsive force. Okay. So, now you see in this, so this is the position when air gap is d0. So, this is the position that we have marked it. Okay. Now, if I put a weight on this, as I put earlier, 200 milligram I put, and then it is touching the bottom one. Now, I will put less weight. I have to make sure that this top wire should not touch the bottom wire. Okay. So, in top wire I will put weight say 50 milligram. Okay. So, when I will put 50 milligram, then it will rotate, it will bend, rotate, right, not bend, here it will rotate, free oscillation, free rotation, it will rotate. So, why it rotate? Because its axis is here, its axis is here with respect to this axis, so it can rotate freely. So, now at this distance, at this perpendicular distance, I have put mass say 50 milligram. So, mg, that force is acting downwards. So, force is acting downwards, and this distance from this axis is this one. So, there will be torque, This torque is basically this force, cross product of force and this distance from the axis. Okay. So, if force direction is this and distance, that direction is say this way. So, in other third direction, that will be the axis of that will be this torque direction will be this third direction. So, that is basically the axis of rotation. Okay. So, that is why if I put weight, so it will rotate, okay, due to torque. Okay. Now it will come down because it is rotate. So, it will come down. So, I will mark that position when it will come down, I will mark that position. Now, from that position, okay, now if I apply current, now this gravitational force is acting downwards. Now, if I apply current in opposite direction, then there will be repulsion. So, it will act in other way. Okay. Force between these two wires will act in other direction. Okay. So, then again torque, but in opposite direction. So, it will rotate back, Okay. So, when it will rotate back, mirror is rotating. So, this reflection rays also will move up. So, I will apply current, I will change current to bring this spot to this original position. Okay. So, when it will come at original position, then these two force will be equal. Okay. One force is this Lorentz force F, this Lorentz force, that F will be equal to gravitational force mg. So, F will be equal to mg. Okay. So, this is the way we will find out, we will basically measure the F Lorentz force due to current I. So, that current we have to find out for which current this force, Lorentz force will be equal to mg. Okay. So, these are the techniques we will use, and this is the main part of this experiment. Okay. So, let me demonstrate that one. Now, at this position air gap is d0, right, air gap is d0. Now, let me put a weight, that is, I think I have to find out. I do not want to put 200 gram, then it will touch, so let me put 50 gram, 50 milligram, of course. So, I have this may be 20, it is a 20 I guess. So, this will be 50. So, this 50. So, basically we will later on we will measure this weight, recheck this weight using our digital balance. So, its accuracy, I think it's in microgram. This accuracy of this balance least count is microgram. So, using that one we will verify this weight, and actual weight I will take later on. I will not show here, but we have arrangement. Okay. So, using the microbalance we will later on take this. So, now approximately we can tell this the 50 milligram. So, this 50 milligram I will put this 50 milligram. Okay. I will put this 50 milligram. Okay. It is fallen down. So, I should put, okay, I have put, okay. So, I think it should, I should, I do not know, but I do not, yes, I think it should come to the, static position. Yes, more or less is static. Okay. Okay. Still I have to okay. So, it's, but does not matter. I have to just, you see so it has not reached at this point, that means it is not touching. Okay. So, it has to be, after putting weight, it has to be above this point, then we are sure that these two parallel wires are not touching each other. Okay. So, now it is at this position. Okay. So, I do not need this reading basically, but you can mark it, but without marking also fine, because my task is to bring it back to this position, and for that how much current I have to apply. So, now 50 milligram I have put, so there is the downward force is mg, that is there. Now, I will apply current. Now, you see I am applying current. So, is our current source. I will switch on, okay. I will switch on, okay. So, is 0 current now, Now, I am in just applying current, I think, yes, 1 ampere, I have put 1 ampere, then 2, 3, I am changing reading. You see, it is going up now, okay. I have to increase current and I have to take it, you see, it is going up. So, one has to see I have to give slightly more current, I have to give slightly more current, slightly more I will give. Okay, it is oscillating with respect to this point. Slightly more I would prefer to give, I would prefer to give slightly more. Yes, no, I need slightly more. Yes, now it is in middle. Okay, so here at this just it has is I think slightly I am touching, so that's why it's slightly misaligned. So it's so what is the reading of current? 11.1 ampere. This current is 11.1 ampere. So I have to note down this current. I have to note down this current. I have to switch off because otherwise it will be on. So now I know the reading, I know the reading, so I reduced and then switch off because okay. So for you have to take, you have to reduce current within very short time, because otherwise if current passes through this wire, high current 11.1 ampere, very high current, okay. So these things, this rod will be hot and yes, it may bend also, okay. So this gap now then it will change. So that precaution one has to take. So this the let me show you the table here. Let me, I think, okay, this table you can see the serial number, this weight I have put this 50 milligram, right. I will write this one. Then here I have written forward current, reverse current, forward current, reverse current. To bring it back, how much current I have to apply. So if it is, we take forward current, okay. So then I have to write here 11.1. Then I will reverse the current. Current are in opposite direction, that is there. So whatever the in top, whatever the direction was this and bottom direction was this, or vice versa, okay. Now I will just do opposite. So this current will be reversed and automatically the other one will be reversed, okay. For that what I have to do? I have to just here I have to change the polarity. So this I will change these two, okay. So yeah, so I will just exchange this. So thus I change the polarity, okay. Now if I switch on and this apply this, I think just check how much, I think let me check once more. So this weight is there already, okay. Now in reverse, for reverse current I will yellow wire, yes. So yes, so now I will apply current, you see. So I know this, it will be around 11. So let me go quickly, okay. Okay, so this reading is 10.2. For 10.2, I think slightly more I should give. Yes, so 10.8. Earlier it was 11.1, now it is 10.8, or slightly reduce. I should slightly reduce. Okay. Yeah, so it's around 10.6 or 10.8. So we have to take reading. Note down this, we are telling current, reverse current, okay. So there I will note down 10.8 or 10.6, okay. Now mean current I will take this plus this by 2 mean current, and force is mg. So I square, I will find out I square. So F and I square, this one set of data I got. So then I will put 2 20 milligram, I will increase by 20 milligram. Let me reduce this current, okay. I reduce the current to 0, then switch off, okay. So, we should switch off. So, this way I will, since this 50, then I will take 70, I will put weight 20 more, 70, again I will repeat the experiment, then 90, then 110, then 130, at least 5 data I need, and then now I have F versus I square graph I can plot. So, I will plot F versus I square graph, and yes, and then basically all things are in your hand, all data are in your hand, and you can calculate. I think, yes, I don't, okay, I have not written. So, now working formula, just let me go to the working formula. Yes, working formula, as I told that I will plot this F versus I square graph. From there I will find out the slope, and this slope I will put here, and D is already I have measured, D already I have measured, and L also I have already measured, and then we will find out the mu. Okay. So, this is the one nice experiment, how to find out the permeability of air medium. Okay. So, I think I will stop here. Thank you.